Hey there. Continuing where I left off. A fifth concern that we should take into account when considering the statistical validity of a correlational study is whether or not there's a restriction of range. What does restriction of range mean? Well, let's say we're a college. And let's say we're one of those Ivy League universities, all right? And we're wondering whether there is a correlation between SAT score and GPA. So we get a whole bunch of people and measure their SAT score, and we measure their GPA, and lo and behold, we get a moderate positive correlation. Now, is there a restriction of range? Well, lots of these Ivy League schools, right, have a cutoff for their SAT scores. And let's say that we accept only students over 1200. Only students with an SAT over 1200. So we're not considering students with an SAT below 1200. In other words, we don't consider the full range of SAT scores when considering our correlation between SAT and GPA, and therefore we have restriction of range. Right? There's the full range of SAT scores, but for our purposes we're only looking at scores 1200 and up. And so we may be tempted to conclude that there's a moderate positive correlation. But since we don't know what happens here, our conclusions are pretty limited. Now, there could be a good reason why scientists would only include a narrow range. For instance, we at our Ivy League university could potentially only be interested in our students, in which case there's no point in looking at SAT scores below 1200. Right? But for our statistical validity purposes, if we don't know what happens below 1200, we can't make any conclusions about that. Right? So that's what restrictions of range means. For instance, it could look like this. We don't know if we haven't collected that data. This is made up data, of course. Right? And that would, change our conclusions perhaps. In this case, it wouldn't, because we still would see a moderate positive correlation between SAT score and GPA. But what if our dot cloud ended up here? Right, then we would have a very different conclusion. Right, so when we evaluate a correlation between two variables, we have to be concerned about whether or not there's a restriction of range with one or even perhaps both of these variables. And if there is, we have to wonder, well, what if we look beyond that range? Would our correlation potentially look different? For instance, it could be the case that our data would look something like this, right? In which case our conclusion would be very different. Which brings us to our next concern. Perhaps the association is curvilinear, right? In most correlations, we start out assuming that the relationship between two variables is linear. Not curvilinear, like a U shape, or maybe an inverse U shape, or something else. Right? Let's say that some researcher was wondering between the relationship between the use of the healthcare system and age. Right? And without looking at the plot, that researcher correlated the correlation coefficient, the linear correlation coefficient, and observed a correlation coefficient of 0. This is actually what you would get if you were to compute the correlation coefficient between these two variables. But the plot suggests that there's not a linear correlation, but that there's a curvilinear relationship, right? A U-shaped. After all, when we're just born, our mother would take us to the doctor for very little things. If we cough, our mother takes us to the doctor because, a baby coughing is potentially important. And we get all kinds of childhood diseases. Then when we reach our teens or our 20s or 30s, there's hardly ever anything wrong with us. So we hardly ever visit the doctor. And then we reach middle age. And then our doctor visits will gradually increase again, right? So a researcher who would only, for instance, look at middle-aged people like me and up, right? So middle age and up, might conclude that there's a linear relationship between age and doctor visits, right? But this would be incorrect. That would only go for middle age and up, but for the entire age range, the relationship is U-shaped. Again, that's called curvilinear, or inverse U-shaped, right? Like L-shaped. That's also possible for some variables. So I talked about all of these. When considering the statistical validity of a correlation, of an association claim, we have to ponder all of these questions, right, that I talked about. How strong is the relationship? How precise is the estimate? Including the statistical significance of the estimate. Has the finding been replicated? Are there outliers that could be responsible for the association or could in any way, shape or form affect the association? Is there restriction of range that could influence the validity of the correlation? Or is the statistical validity? Or is it possible that there's a curvilinear rather than a linear relationship?